Hi guys, welcome to today's class. Today we're gonna go over chapter 2 and get some problems done. Alright. Alright, what is this? This is a very important figure that end of each chapter you'll later see what it talks about it. Pretty sure. I think it's somewhere after this. Um Probably will take some time. Anyways, get started. What is an angle? I'm pretty sure you guys know what an angle is. When two rays share an origin, they form an angle. Yes. I'm pretty sure you guys understand that. And of course, two intersecting lines also make an angle. This is the angles they're talking about. All right, so now let's move on. Pretty sure you guys understand this also. Use your protractor to find YOZ. I don't think I have a protractor. Yeah, I don't have a protractor. YOZ, it's clearly a 90-degree angle. CXD, you can eyeball it. It's like around 30 degrees. And this is like 75 degrees, you could say. And then the diagram shows four common angles. In each case, one point O is in the center of the circle. AOB cuts 1/4, 1/3, and then 1/12 and 1/8. And you can literally just guess the answers, right? So GOH seems to be 45 degrees. This one seems like 30 degrees. This one's like 120 degrees and 90 degrees. I'm pretty sure you guys all know these famous angles: 30 degrees, 45 degrees, 60 degrees, 90 degrees, 120 degrees, and so on. Basically, most of them are multiples of 15. All right. And this gives you some angle calculations and how to use the protractor. All right. I'm pretty sure you guys understand this. This one we can skip because I don't have a protractor, and frankly, it's quite simple. All right. Use your protractor to measure the angles shown below. Classify each angle as right, acute, and obtuse. All right. I always guys try to classify these angles as right, acute, and obtuse. All right. So let's you guys have a try this question and tell me your answer to chat. Let's get started with this question. So this one's a cute. Uh, this one's a cute. This one's obtuse. This one's a cute. And these all three are all cute. All right. And these are taking about straight and angles and vertical angles. These are vertical angles. Like opposite angles are the same. And straight angles just 180 degrees. All right. So I'll let you guys have a try on X on 2.3.1 and 2.3.2. All right. I think these are pretty simple. I think you should be able to do these. All right, let's get started. So, what is the 2.3.1? Well, this is basically a straight angle, right? So the total is 180 degrees. I'm pretty sure you guys understand that. So this is gonna be 65 degrees. This one is also gonna be 65, and this will be 150. Vertical angles property. Supplementary, we all know that's 180 degrees minus, right? Or they when they add up to the angle, they form 180 degrees. So this one's 60 degrees, 135 degrees, and 90 degrees. And complementary is just 90 degrees. They sum up to 90 degrees. So this is 60 degrees, 45 degrees, 15 degrees. I'm pretty sure you guys understand this. And parallel lines, which is pretty obvious, is they just call the same exact slope or same direct direction, same direction, like this. They go the same direction. I'm pretty sure you guys understand it. And find x and y in the diagram and show that a equals c and b equals d in the diagram. All right. Why is a equals c and b equals d? Well, we can first draw a perpendicular. We can first notice that this is a transversal line. We'll all understand it. Pretty sure you guys understand the basic concepts of angles, vertical angles, transversals, parallels. Yes, I'm pretty sure you guys understand that. We extend these lines into lines, all right? This angle will be equal to this angle. These are alternate interior angles. I'm pretty sure that's what they called. A and E are alternate corresponding angles. D and F are alternate interior angles. Yep, that's right. Which means, and these are vertical angles, all right? So this is a corresponding angle. That's the same. And this is also a vertical angle. So we prove that this is equal to that. And same thing, you can prove it. This one is equal to that one. All right, proved. Y is going to be an alternate interior angle, I'm pretty sure. Oops. Anyways, please do not annotate on the screen. I've disabled it. Anyways, this is just this is a very important law. It's a part of the parallelogram, and you're gonna learn about it in the future. It's very, very important. Alright, solves a lot of problems with the parallelogram. Same thing as here. You can just draw another line. You see this is parallelogram, right? These are corresponding angles. These are corresponding angles. And you know that y is equal to 118 degrees. Why? Because the 118 degrees and this angle right over here is alternate interior. And then x is just the supplementary, alright? So basically 180 minus 118 or 162 degrees, right? So that's equal to x. Y is equal to 118. Okay, now I was gonna have a try on 2.4.3 and 2.4.4, right? Let's see how to try on this question and tell us to private message. All right, let's get started with this question. So we noticed that 2x minus y and 3x plus y are supplementary angles, right? So 2x minus y plus 3x plus y is 180 degrees. Which adds up to 5x is equal to 180, or x is equal to 36. And then you can find, and this is an answer, that's just 36. They obviously made it so that it's not a two variable equation. Clearly, it's minus y and plus y. Clearly, if it wasn't a two variable, if it wasn't only that one equation, then we would have been stuck, right? And in the diagram below, m equals n and the angles are marked. Find x. All right, this is I think a cool fact. We're gonna derive it right now. So, well, I think I remember the formula. I claim that 35 plus 40 is equal to x, right? That's the angles, to sum it up. Now here's the proof. The total measure of an angle in the pentagon is 540 degrees. And these, let's say they're right angles, right? They sum up to 180 degrees. Now we have the 35 degrees and 40 degrees. And that should be equal to 360 minus x. Notice that if we add these all up, we will have an extra 35 plus 40 degrees. And that will be x. Why? Because 360 plus 180 is equal to 540. So our answer is 35 plus 40 degrees, or 75 degrees. It's a very, very cool formula. It's easy to derive. And I don't think you guys need to memorize this one. Alright? Now let's move on to 2.5. 2.4.5. In the diagram at right, K is parallel to L and M is parallel to N. If the angles are as marked, find X and Y. Let's give it a try on this question and tell us to chat. Well, let's get started with this question now. So K is parallel to L and M is parallel to N, right? These lines are parallel. And we want to find X minus Y. We want to find X and Y. Clearly, since we have the negative Y and plus Y again, you might as well just do the usual. Add them up. We get 2x is equal to 180 degrees and x is equal to 90 degrees. Now, we're also given x plus y is also equal to 2x minus 2y. And we're already given x is 90 degrees. So it's 180 degrees minus 2y is equal to 90 degrees plus y. Or 90 degrees is equal to 3y. Or y is equal to 30. This is really guessable. This looks like a 60 degree and this looks like 120. 60 degrees and 120 degrees. I meant 90 degrees and 30 degrees. Well, their corresponding angles are 60 degrees and 120 degrees. And now this is just angles of a triangle. We just, same thing as angle chasing. We just need to know that the sum of the angles in the triangle is 180 degrees. And we have three sides and three angles. And we have one example. And I want to give you guys a try on 2.19. Let's see if you guys can do this. Right? In the diagram, M is parallel to N, AB is perpendicular to M, ADC is equal to BC equals 3x, CB is equal to 50 degrees, and BCD is equal to x. Find x. I'll just give a try on this question and turn this to chat. All right, let's get started with this question now. All right, so this is basically angle chase. I'm pretty sure you have done that before, but this is just basically finding the angles using triangle angle formulas, vertical angles, supplementary angles, or on the occasional trigonometry. All right, this is pretty simple. All right, so how do you do this? Well, notice this is 50 degrees, 30 degrees. We have, we can find this angle. All right, we can find that angle. We have ADC. You know, BC, CB is equal to 15, BCD is equal to X. We want to find X. Well, I want to show that this is 90 degrees. And this is indeed, since there are transversal lines. Alright. 3x, this is just 180 minus 3x. And this is just 90 minus, well, what is this angle? This angle is just 180 minus 50 plus 3x. This is the very essence of angle chasing, you must know. 130 minus 3x. This is 130 minus 3x. 90 minus that, that's just 3x minus 40. That's 3x minus 40 over here. And we're adding this all up. We get 140 plus x is equal to 180 degrees. And then x is equal to 40 degrees, if I'm right. Am I doing this right? Let's see. This is 130 minus 3x, that's 10 degrees. 120. Yeah, I'm doing this right. And that's how you solve it. Or you can just find the angle chasing and go over here. Maybe that was another way to do this. Let me see if I was doing this right. What's 120 degrees? 4x is 160 degrees. This is 20 degrees. This is 40 degrees. Yeah, this is correct. 100% correct. So the answer to this question is just 40 degrees. Shows you an example of how you can angle change to find your answer. It's basically using triangle angle formulas, uh, parallel lines, perpendicular lines. Just find your answer. It's basically the very essence of how you angle change. All right. Let's move on to 2.5. Two angles have in triangle measure 30 and 57 degrees. What's the measure of third angle? The sum of the angles in the triangle is 180 degrees, so you can subtract and get 93 degrees as your third angle. The angles in the triangle is ratio 1, 2, 3. What's the measure of the angles? Well, that's the total. Say, remember ratios we talked about before? Well, the ratio, let's say the part is x, right? Summing this all up is give you 6 parts, or 6x. And this is equal to 180 degrees, since the total sum of all the angles in the triangle is 180 degrees, or x is 30 degrees. Now, what are the measure of the angles? That would be 30, 60, and 90. 1, 2, and 3, respectively. And we want to find ZYP in the diagram now. We're given these angles, and what do? We angle chase. 58, 29, what is the thing we can find? Well, we don't need to find this angle. We don't need to find this angle. We can just go up to straight to the shortcut and find this angle. This is just 52 plus ZYP. And we add this to 58 and 29, which gives you 87. And you should get 180 degrees in the triangle. Summing this all up, this gives you 139 plus the wanted angle is equal to 180 degrees. Do subtraction, and you should be left with 41 is equal to ZYP. Now we have this one. One of the angles in the triangle is the right angle, so that the other two angles are complementary. Well, this is clearly the case because why? Because the sum of the angles in the triangle is 180 degrees, and subtract 90, that's 90 degrees, so they're complementary. Using what you know about angles, find a different solution to 2.14. All right, what was the solution of that? Let's see where it was. Find x. All right. And they did a bunch of, they added a new parallel line. I guess that's how they did it. I gave you a formula. I think you guys know how to do it. I think you guys know how to use it. All right. I was just gonna try this question and tell me answer to chat. And remember the last formula we used? I think it was over here. Remember this formula? Sum of these two angles in this triangle, these two angles is equal to the right angle, x. Try using this formula to help you solve this question, alright? Let's go try this question and tell me answer to chat. Let's get started with this question now. So I'm pretty sure you guys understand the method that I was teaching you. This is a very important angle if you want to find x, right? I'll use a light green color, right? Why is that? We know what this angle is, right? This is 50 degrees. Remember what we talked before. We said, given any length, we have two parallel lines. We have two parallel lines. And we have this figure, all right? We proved that, say, this angle A and this angle B, we proved that A plus B is equal to C. This will hold true. This is true. Now we can apply this formula to this example. All right? We'll apply this formula to this example. We can see A in this case, this is A, is 50 degrees. X is equal to B. And the 90 degrees is equal to C. Applying this to the formula in, plugging it in, you get 50 plus B is equal to 90 degrees, or X. We write X. Or X is equal to 40 degrees. So the answer is just 40, which is indeed right. So that's it for today's class. I hope you guys have a wonderful weekend. I'll see you next week. Bye.